Welcome students to my channel Chemistry World. Today I shall discuss a problem on haloalkanes. So this is the second problem of this chapter on this channel. So you can see the problem. The major product in the following reaction is a substrate is given and the reagent is tertiary butanol and heat is applied. Four options are given. You can see the option. Quickly note down the question and also the options. You can take a screenshot of it. Now let's start the solution. Okay. So to solve this type of problem, we have to first write the substrate and the reagent or the conditions given. So this is our substrate. Okay, so this is our substrate. Okay, so this is carbon CH3, this is CH3, this is CH3, this is CH3, and this is CH. One hydrogen is attached to the carbon, and here also CH. Okay, so this is the substrate. Now tertiary butanol is the reagent. Tertiary butanol is the reagent and heat is applied. So which type of reaction is this? This is an alkyl halide. This is halide, this is halogen, this is iodine, this is the halogen, and this is a alkyl halide. So in alkyl halide, tertiary butanol is given and heat is applied. So this is what happened. Elimination will happen. Elimination reaction will going to happen. Okay, now we know that elimination may be two type in general, that is E1 or E2. So which case is applied for this type of substrate? Now you can see that this is a secondary halide. This is a secondary alkyl halide. Okay, and the base is a bulky base. Okay, and also you can see that heat is applied. So in that case, E1 elimination will occur. E1 elimination. E1 means elimination unimolecular. Elimination unimolecular. So in that case, At first, this iodine molecule will remove and a secondary carbocation will be formed. Okay, so in that case a secondary carbocation will be formed. So the carbocation will be this is the carbocation which will be formed okay. Please write down the carbocation. Now we have to find that this carbocation is stable or not. This carbocation is stable or not. So we have to calculate the number of hyperconjugative structure. Okay, this is a primary carbocation or secondary carbocation. This is also a secondary carbocation. This is a secondary carbocation. Okay, now in secondary carbocation, this is a secondary carbocation. This is a secondary carbocation. So how many number of hyperconjugative structure is possible? So you can see that here 3 hydrogen attached to the adjacent carbon, and here 1 hydrogen is attached to the adjacent carbon. So total 4 hyperconjugative structure is possible. 4 hyperconjugative structure is possible. Now we have to investigate, is there any chance of hydride shift? Is there any chance of hydride shift to form a more stable carbocation? To form a more stable carbocation. So I shift this. Now we can see that if this hydrogen is shifted to this carbon, then what happened? Then what happened? This type of carbocation is formed. Okay. Now how many hyperconjugative structure is possible? What is the type of carbocation? This is a tertiary carbocation. This is a tertiary carbocation. Okay. Now we know that tertiary carbocations are more stable. Tertiary carbocation, this is a tertiary carbocation, and we know that tertiary carbocation is more stable than the secondary carbocation. We can also find the number of hyperconjugative structure. Here 3 3 hydrogen, you can see this is the 3 hydrogen attached to the adjacent carbon, and here 2 hydrogen attached to the adjacent carbon. Okay, and here 1 hydrogen is attached to the adjacent carbon. So total 3 plus 1 plus 2, total 6 hyperconjugative structure is possible. So this carbocation is more stable. Okay, so this is formed after 1,2 hydride shift, 1,2 hydride shift. Okay, so this carbocation is formed. A tertiary carbocation is formed. Okay, now next step is elimination of hydrogen. So which hydrogen is eliminated? This hydrogen or this hydrogen. Okay, so I marked it as H1 and H2. If H1 is eliminated, a less substituted alkene is formed. But if H2 is eliminated, a more substituted alkene is formed. So we know that more substituted alkene is more stable. So in that case, H2 is eliminated and a more substituted alkene is formed. So in that case, this hydrogen is eliminated. So minus H plus and what is formed finally? So this product is formed. So this product is resembles with, match with which option? Which option? So this is option C. Okay, so the correct option is option C, a more substituted alkene. So again we revise our thinking. This is a secondary alkyl halide. Okay, and the reaction proceeds through E1 mechanism. At first a carbocation is generated, a secondary carbocation. After that 1,2 hydrogen shift is occur to generate more stabilized tertiary carbocation, and finally hydrogen is eliminated to yield more substituted alkene, that is C. Okay, so my dear students, you think about this problem in your own way and try to solve this type of problem. Revise this type of problems, because this type of problems may be asked in different competitive examination like NEET, WBJEE, JEE mains, or other competitive examination. And for this type of questions, you please subscribe my channel and turn on the bell. Okay, thank you so much for today.